Today's notes are on solving quadratic equations by factoring and solving quadratic equations by taking the square root. Some important properties for you to know is first the zero product property, which says if a and b are real numbers and a times b equals 0, then either a equals 0 or b equals 0. Not all equations can be solved by factoring. If an expression cannot be factored, then other methods must be used to solve the equation. Your steps for solving an equation by factoring are to first rewrite the equation so that one side is equal to 0. Then you will factor the non-zero side completely. The third step is to use the zero product property by setting each factor on the one side equal to 0 and solving the resulting equations. These solutions are referred to as the zeros of the function. Common mistakes to avoid. The zero product property can only be used when the product is 0. It is not true, for example, if a times b equals 6, and then a equals 6 or b equals 6. It has to be equal to 0. Also, remember that only factors containing variables lead to solutions. And although you may divide each side of the equation by a non-zero number, do not divide each side of an equation by a variable. This may result in you losing a solution. So let's go down and look at the first couple of examples. We are going to factor the quadratic equation and solve using our factoring methods. So the first thing I want to see is that the right side of the equation is equal to 0. Next, I'm going to factor the left side. A is equal to 1, so I want to know what multiplies to 15 and adds to negative 8. So my factors of 15 are 1 and 5, or 1 and 15, and 3 and 5. So I'm going to be using a negative 3 and a negative 5. Once you have factored the left side of the equation, you're going to solve by setting both factors equal to 0. So either x minus 3 equals 0 or x minus 5 equals 0. So if we solve, we get x equals 3 or x equals 5. We're going to do the same thing for example 2. I want to start by moving everything to one side of the equation, and I want my x squared term to be positive. So I'm going to move everything to the left side. And because my a term is something other than 1, I'm going to have to use the AC method and then factor by grouping. So I want to know what multiplies to negative 24 and adds to negative 5. So I get 1 times 24, 2 times 12, 3 times 8, and 4 times 6, and I'm trying to add to negative 5, so I'm going to be using a positive 3 and a negative 8. And I'm going to group the first two terms together and the last two terms, and we'll separate them with an addition symbol and pull a greatest common factor out from each. So this factors to 2x plus 1 and 3x minus 4. So now that we've factored, we're going to take each factor and set it equal to 0 and solve them separately. So we get 2x is equal to negative 1, or x equals negative 1/2, or 3x equals 4, or x equals 4/3. Flip to the next page. We're going to look at example number 3. Right, for example number 3, remember that the zero product property only works if one side is equal to 0. So I can't just subtract the 9 over. I first need to combine the terms on the left side by distributing the x. Then I can subtract the 9 over to get 2x squared plus 3x minus 9 equals 0. Now we can go through with using the AC method again. So I'm trying to figure out what multiplies negative 18 and adds to 3. So I get 1 and 18, 2 and 9, and 3 and 6. So I'm going to be using a negative 3 and a positive 6. 2x squared minus 3x plus 6x minus 9. And I'm going to group the first two terms together and the last two terms together and pull out a greatest common factor in each. So I get 2x minus 3, and then x plus 3 equals 0. So since I'm done factoring, I'm going to set each factor equal to 0, and we're going to solve. So the first one, I add 3, and then divide by 2. The second one, I just need to subtract 3 from both sides. So we get x is equal to 3 over 2, or x is equal to negative 3. All right, please look at example 4 through 8 on your own. Give them a try, and we will go over them tomorrow in class. After you finish looking at examples 4 through 8, turn to the next page to look at solving by square roots. Before we can look at solving square roots, we need to remember the properties of square roots and remember simplifying them. So first is the product property that tells you you can pull the square root apart to be the product of two separate square roots. Same with the quotient property. I can take one quotient and separate it into two separate radicals. So for the warm-up, number 1, I want to simplify the square root of 700. So we're going to do this by making factor trees. So I want to think of any two numbers that multiply together to give me 700. So I'm going to use 7 and 100. And then because 100 is a perfect square, we can simplify this to 10 root 7. But I also have the 3xy that's there, so I end up having 3xy times 10 root 7, and the 3 and the 10 multiply together to give me 30xy times the square root of 7. See if you can use the same properties to simplify number 2. On number 3, we want to use the quotient property, which tells us that we can pull this apart to be two separate radicals. And in the numerator, the only thing I can do is pull out an x, which will leave me with 7x x inside the square root. In the denominator, 25 is a perfect square, so the square root of 25 gives me 5. Please use the quotient property and see if you can simplify number 4. Next, we want to review rationalizing the denominator. Remember when you do this that it means to make the bottom of the fraction a rational number, so we want to get rid of the radical. It is improper form to have an irrational number in the bottom of a fraction. To rationalize the denominator, you need to multiply the fraction by a value that creates a perfect square underneath the radical sign. So for these examples, we are going to simplify and then rationalize the denominator. So the first thing I'm going to do is use the quotient property to pull this apart into two separate fractions. Then we need to multiply the numerator and the denominator by something that creates a perfect square in the denominator under the radical sign. So in order to do that, you're going to multiply by whatever is already underneath the square root. So I'm going to multiply everything by the square root of 7. This gives me the square root of 14x over the square root of 49. And 49 is a perfect square, so that simplifies to 7. So this is simplified. I can't simplify the numerator anymore. Nothing cancels out in the denominator, and I got rid of my radical in the denominator, so we're done with example 1. Please go through and try to rationalize example 2 on your own. Remember, you only have to multiply by what's underneath the square root. Now that we've brushed up on our properties of square roots, we can solve by using square roots. So in order to do this, we are going to get the square term by itself, and then take the square root. Alright, so in example 1, the square term is just the x squared, so I'm trying to get that by itself. So we'll need to add 6 to both sides. And then divide both sides by 4. To get x squared is equal to 12. So now that we have the x squared by itself, I'm going to take the square root of both sides. The square root of x squared gives me x. You want to remember that you can get a positive or a negative number from a square root. So I get plus or minus the square root of 12. Then we do have to simplify the square root of 12. 12 can be broken down to the square root of 4 times the square root of 3, and 4 is a perfect square, so this turns into 2 root 3. So we get x is equal to plus or minus 2 root 3 as our answer. We're going to do the same thing for example 2. This time I'm trying to get the quantity squared by itself. So in order to get rid of the 2 in the denominator, I'm going to multiply both sides by 2. So I'll get the quantity x plus 4 squared equals 120. Then to undo the square, I'm going to take the square root of both sides. The square root of a quantity squared is equal to whatever that quantity is. So x plus 4 is equal to plus or minus the square root of 120. And I need to simplify the square root of 120. So 120 I can break down to 4 times 30, and 30 can be broken down to 2 times 15, and then 3 times 5. So the only perfect square is the 4. So this whole thing equals 2 square root of 30 because there's not another perfect square for me to pull out. So I'm at x plus 4 is equal to plus or minus 2 root 30. And we're going to subtract 4 from both sides. The negative 4 goes out front in front of the plus or minus. So you get negative 4 plus or minus 2 square root 30. Please try and do examples 3, 4, and 5 on your own. Remember that for 3 and 4, you want to get the quantity squared by itself before you take the square root of both sides. We'll talk about the rest of these examples tomorrow in class.